We built the James Webb Telescope for one main reason: to look back to the very beginning, to see the birth of the first stars and galaxies. It's the most powerful time machine we've ever created. But what if that first chapter of the universe's story is all wrong? What if the dawn of time isn't what we thought it was? Not long ago, NASA confirmed the discovery of one of the oldest, most distant objects humanity has ever laid eyes on. It's a galaxy officially named JADES GS-Z14-0, and it was already there when the universe was less than 300 million years old, just 2% of its current age. Now, this isn't just about breaking another record. This galaxy is doing something that, according to our best models of the universe, should be flat out impossible. It's so big, so bright, and so complex that it has top scientists, including Nobel laureates, seriously concerned. As Nobel Prize winner Adam Rice put it, findings like this suggest we have misunderstood the universe. So, what did Webb actually find at the edge of time? And why is it forcing us to question the entire history of the cosmos? To really get your head around this discovery, you first have to travel across an almost unimaginable distance of space and time. When Webb points its giant golden mirror at a seemingly empty patch of sky, it's not just looking out, it's looking back. Light, as fast as it is, still takes time to get from one place to another. The light from our own sun takes 8 minutes to reach your eyes. The light from the next star over, Alpha Centauri, takes 4 years. The light from JADES GS-Z14-0 has been traveling for over 13.5 billion years to reach us. We are seeing it as it was just 290 million years after the Big Bang. Think about that for a second. If the universe's entire 13.8 billion year history was a single calendar year, the Big Bang is January 1st. All of human history happens in the last few seconds of December 31st. This galaxy we're seeing existed in the first week of January. It's a true fossil from the cosmic dawn. Astronomers measure these crazy distances using something called redshift. It works a bit like the Doppler effect. You know how an ambulance siren sounds higher when it's coming at you and drops to a lower pitch as it drives away? Light does something similar. As the universe expands, it stretches the light traveling through it, shifting it toward the red part of the spectrum. The farther away an object is, the more its light gets redshifted. When JADES GS-Z14-0 was discovered, it shattered the old distance record with a confirmed redshift of 14.32. While that record has recently been edged out by another galaxy called MOM-Z14-44, which has a redshift of 14.44, JADES-ZS14-0 remains one of the most important and baffling objects ever found. Finding it was a massive achievement. It took Webb's near-infrared spectrograph, or NIRSPEC, nearly 10 hours just to gather its faint ancient light. When the science team saw the data, they were floored. The evidence was undeniable, but that moment of celebration was immediately followed by a wave of confusion. The numbers just didn't make any sense. According to the standard model of cosmology, our grand theory for how the universe works, the first galaxies should have been tiny, dim, and pretty simple. Right after the Big Bang, the universe was basically just hydrogen and helium. All the heavier elements that make up you, me, and the world around us, what astronomers just call metals like oxygen, carbon, and iron, had to be cooked up inside stars and then scattered into space when those stars died. That whole process was supposed to be slow. The first galaxies should have been small, scraggly collections of stars taking billions of years to build up their mass and complexity. But that's not what Webb saw. JADES GS-Z14-0 isn't some faint, primitive smudge. It is shockingly bright, 5 times more luminous than the previous record holder. And get this, the galaxy itself is enormous, stretching over 1,600 light-years across and weighing in at hundreds of millions of times the mass of our own sun. NASA scientists were left asking a huge question. How did nature build something so bright, so massive, and so big in less than 300 million years? The light isn't coming from a supermassive black hole, which can get incredibly bright. Nope, spectroscopic analysis confirmed the light is almost all from young stars. This means the galaxy is churning out new stars like crazy, about 20 a year. But here's the real shocker. The galaxy's light spectrum showed the clear fingerprint of oxygen. Finding oxygen that early in the universe is like finding a fully built skyscraper in a photograph from the Stone Age. It means at least one generation of massive stars had to be born, live their entire lives, and die to seed the galaxy with these heavy elements. This whole cycle happened way faster than anyone ever thought possible. As one University of Arizona researcher, Kevin Hainline, put it, nobody dreamed that there would be galaxies this bright at this high redshift. The discovery team flat out admitted that Jade's GS Z14-0 is nothing like the galaxies predicted by their models.
This is where the pure thrill of discovery runs into a deep scientific worry. The existence of Jade's GS Z14-0 and other shockingly mature galaxies Webb keeps finding doesn't just bend our theories, it punches a hole right through the foundations of cosmology. These discoveries are so profound, they've led some to declare a crisis in cosmology. And this worry goes right to the top. John Mather, a Nobel Laureate and a senior project scientist for the JWST, admitted that the first galaxies Webb found are surprisingly big, bright, powerful, and numerous compared with what we expected. Coming from one of the telescope's chief architects, that's a huge deal. Adam Rees, who won the Nobel Prize for helping discover dark energy, has been using Webb to investigate another major cosmic puzzle called the Hubble tension, a big disagreement over how fast the universe is expanding. Instead of solving it, Webb's precise measurements have only deepened the mystery, confirming the conflict is real. Rees stated that these kinds of findings force us to consider the real and exciting possibility that we have misunderstood the universe. The worry isn't that the Big Bang theory itself is wrong. It's that the story we've been telling ourselves about what happened after the Big Bang is way too simple. Our standard model of cosmology, called lambda CDM, has been incredibly successful, but it has a very hard time explaining a galaxy like Jade's GS Z14-0. So, is the theory broken? Maybe not completely, but something is definitely missing. Scientists are now scrambling to figure out what that piece could be. Maybe the first stars were way bigger and burned out faster than we thought, supercharging their galaxies with metals at a shocking speed. Or maybe galaxies can grow much more efficiently in the gas-rich chaos of the early universe. Some have floated wilder ideas, like those from Nobel Laureate Sir Roger Penrose, who speculates these impossible galaxies could be relics from a previous universe that existed before our own. This is science happening in real time. The data is so fresh that even the smartest people on the planet are just starting to figure out what it all means. So what do you think? Are we about to see a revolution in cosmology, or will our theories find a way to make room for these bizarre new objects? Let us know what you think down in the comments. You might think a discovery that threatens to upend decades of theory would be a scientist's worst nightmare, but you'd be wrong. This is exactly what science is all about. It's about pushing boundaries, finding the things that don't fit, and getting excited about the mysteries. Jade's GS Z14-0 isn't really a crisis, it's a clue, a brilliant shining clue that points the way toward a deeper truth about our universe. Some recent studies are already proposing solutions. One idea is that maybe some of these early galaxies look so bright because they have supermassive black holes at their centers that are actively feeding, making them appear more massive than they are. But that just opens up another can of worms. How did black holes get so huge so fast? The James Webb Space Telescope is really just getting warmed up. It's going to keep staring into the darkness, looking for even more distant galaxies, trying to find the very first ones to see if they finally match our predictions. And Webb isn't the last word. NASA's Nancy Grace Roman Space Telescope, launching around 2027, will scan massive sections of the sky, potentially finding thousands more of these cosmic pioneers. We are living in a golden age of cosmology. We built the Webb Telescope to answer our old questions, but its greatest gift might just be all the new questions it's forcing us to ask. Jade's-GS Z14-0 is a monument to human curiosity, a single point of light from the dawn of creation, captured by the most incredible observatory we've ever built. It's both one of the greatest achievements in astronomy and one of the biggest challenges to our understanding of everything. It's a humbling reminder that no matter how much we think we know, the universe will always have another surprise waiting for us, leaving us staring into the night with a profound sense of wonder. If you want to stay on the cutting edge of cosmic discoveries and what they mean for us, make sure you subscribe and ring that notification bell. And for a deeper dive into another one of Webb's game-changing finds, check out the video on your screen right now. Thanks for watching.